Let us talk about binary tree traversal. Binary tree traversal is a traveling technique in the tree. How we can travel in a binary tree to apply different computation at different node. Traveling in a tree is very important because maybe I'm looking for a particular data or looking for a particular information which is inside tree. So in this case we talk about tree traversal classification, then breadth first traversal, then we talk about depth first traversal, pre-order, in-order and post-order. We talk about the reverse depth first traversal and invoking binary trees that causes different expressions. We talk about different methods, and finally we talk about some expression trees and application of expression trees. So binary tree traversal is a very important learning for all of us, and we need to really concentrate. So tree traversal classification, you understand that the process of systematically visiting all the nodes in a tree and performing some processing at each node in the tree is called a tree traversal. That means when I have already a tree and I'm traveling from root to leaf, I'm looking for something and process, this is called tree traversal. So a traversal starts at the root of the tree always and visit every node in the tree exactly once. Please remember once. Why? Because you don't need to visit twice. And there are two common methods in which to traverse a tree. One is called breadth first traversal. That means I do traverse in the tree by level. That means level 0 first, then level 1, then level 2 and so on. This is level order traversal. And depth first traversal, we basically have three types of traversal: pre-order traversal, in order and post order. Question is why this order is coming? Because the way we are visiting the root node. Pre-order means we go to node first, then left, then right. In order means we go left first, then node, then right. Normal order. And it is only applicable for binary tree. And post order means we go left, right, and then at last the node. So what is happening here is the breadth first traversal. We basically have a simple application here, and what we see that it's like a queue is empty, and we are actually talking about this code. If the tree is not empty, we are actually enqueuing the node. Why? Because whatever node I'm visiting, I have to keep that node in the mind. So it's actually traveling across the tree. So let's look at this code. I've just skipped this code because we'll be talking and see. Look at this breadth first traversal technique, which is very important. So breadth first traversal, this is a tree that we have on the left, and on the right you see what I'm traveling. I'm starting with K, then I'm going to 7, and then I'm coming to the next level, and I'm actually, so what is my order? You can see R, A, T, S, M, P, U, F, K. So it's actually reverse, and the other way is the forward breadth first traversal. So that means we are actually traveling in the level. So in the depth first traversal, as you see, what happens in the depth first, we basically have three. One is called pre-order. That means we go to visit the node first, then visit the left subtree, if any, and then visit the right subtree, if any. But please remember, depth first traversal is based on subtree. So pre-order we go node left right. In order we visit the left subtree, then node, then right subtree. And post order we visit the left, we visit the right subtree, and then finally visit the node. So what happens, you see, we basically have this traversal is a recursive implementation. So recursive function call is very important here, and I will show you in C coding how we do it. So look at this pre-order depth first traversal. Pre-order means we go to node first, then left and right. And look at it very carefully that what happens here is your node is starting with the, you start with the node, so you start with the K, and then you understand that you are actually traveling all nodes. So the next node comes is F, and after F you are actually traveling to left subtree. So left subtree is F. So what happens? K, then F, then P is coming, and after P you have the right subtree. So you go into M again, and M, then you come into again left, because it's actually, you can understand that node left right. So we basically have this process, and then finally we come into U. Why? Because I finished the left subtree and now I'm coming into the right subtree. So you understand that I'm doing what? Left, then I go to, I start with the node and then come to left and then come to right. So right, what I have U, and then after this U actually is a node. So where do you go? You go to left. That means you come to S, and S you don't have any left but you have right. So you come into R, and then finally you come into right again, because you have. So what happens? You see, you finish at right, which is T, and you start where? You start at K, that is a node. So you can easily understand that this is right, node, left, right. Alright, so a node is visited when passing on its left in the visit path. Now, in order depth traversal, one will say in order, that means we say that left, then we go to node, then we go to right. So what happens in the left? You see here, in the same tree, I start at the left, and the most starting point is, the starting point I start here is with the P, because P is the left, and then come into node right, that means F, of course, and then come into left again, because I have left, A, and then again my node M, left node, and then I have to come to the node K, because the node K is coming, and then finally you see what happens. After K I'm going to definitely right, so it is coming to S, and after S you are coming into R, because it is actually your right after node. Node is actually, you remember one thing, node is R, and then your node is S, and then you're coming into R. R is actually your right, because node right, and then again node right, because node is U and T is the right. So what you see, you start at P. What is P? P is left. And then in between you have K. See, look at the center is K, is nodes. That means left node. And finally you finish where? You finish at T. What is T? T is right. So left node right. So we understand now, but please remember, you will always not make mistake if you consider subtree. So when you come on the left, consider the left subtree. Always traverse by subtree. So you will never make mistake. So subtree concept is very, very important. So repeat again. You can repeat the whole exercise again. So where do you start? You start at left, P. Then where do you go? You go to node, F. Then where do you go? Because we still have left, you see, A. And then where do I go? Again node. So left node, left node. So that's what we have seen. Now coming to post order. Post order, what happens is left, right node. That means I start at left and then I finish at node. So how? Look at here again. Left, you start at P, and then you come into A, because this is left again, right? Left. Then you have node. There is no right, so you have no right. So here what happens is you come back to M again, and then M, then you have still node F. Fine. After that, what you go? After F, you will actually finish at K. Please remember, you will finish at K, but before that, after F, you have to come to extreme right, because left and now you come into right is R. Then R means right, means then come into node S. Then again where? You're again going to right, T, then you're going to U, and then finally K. So where did you start? You start at left, P, and where did you end? You end at K, which is the node. So left, right node. So remember one thing, every time you do traverse, you consider the subtree. All right. Let's proceed. The reverse depth first traversal is just opposite of pre-order traversal is reverse pre-order traversal, in-order traversal, reverse in-order traversal, and post-order traversal, reverse post-order. That means just the opposite of the normal traversals. And invoking binary traversal technique, we will be actually seeing the C programming code. I will actually talk from the C programming code point of view. I will just skip all this. Expression tree is something very, very important. Any arithmetic expression or logic expression we can actually represent using binary tree. How? Internal vertex represents operator. That means plus, minus, division, whatever operator. I am going to show you. Leaf represent operand. That means A plus B, A, and then there is a plus and then B. And subtrees are sub-expressions. So a binary tree representing an expression is called an expression tree. An expression tree is very important. So building an expression tree is always bottom up. Construct smaller subtree and combine them into a smaller subtree. Look at this. Example, create an expression tree A plus B whole square plus C minus 5 over 3. So A plus B and then C minus 5, these two. Then A plus B, here is going to square, and then that's a square, the power, you see the power operator is shown with 2. And then on the other hand you have C minus 5 division 3, and now you combine them together. In between you have the plus. So you can see the leaf nodes are all operands, and the intermediate nodes are all operators. So operators and operands are distributed in the tree. So expression tree, similar, you can actually do show an expression tree of this compound expression, and you can see how to represent an expression tree. Traversing expression tree in the same as your, when you do expression tree traversing, you say infix, prefix, and postfix is like in order, pre-order, and post-order. So in-order traversal expression tree produces original expression and infix. Pre-order traversal produces a prefix expression. Post-order traversal produces a postfix expression. And that's all from now. We again continue because we will be looking at implementing tree and the complete structure using C programming.